Hello viewers and welcome to our lesson today in mathematics. In our lesson today, we shall look at a topic in Form 3, Formula and Variation. This topic is suitable for students in Form 3 and also in Form 4 for those who are revising for their exams. I am your online teacher, Mr. Steve Getau, and I do welcome all of you to our lessons. This is a series of free online lessons that we are having in this time. Straight away, I would like us to look at this topic and visualize that it is composed of two areas. The part on formula, part 1, involves making a given quantity, a given variable, the subject of the formula when you are given that formula. So this part, we shall go through it in form of examples. Then we shall look at part 2, which is on variations, the various forms of variations, the 4 of them, and we shall look at examples in each case. Now, this lesson is a recorded lesson, and we are going to have about 40 minutes of the discussion, and then I'll let you have an activity. The activity will be composed of a few questions which learners and viewers, you will answer, and then I'll go live and get your feedback in about 20 minutes so that the entire lesson is about 1 hour. Welcome, and let's get going. In part 1, making some variable the subject of the formula, we shall start with example number 1. So viewers, let's have our notebooks, and as we discuss, be writing so that we can make reference to this material. Number 1, we are required to make P the subject, make P the subject of the formula. Make P the subject of the formula. Given an expression like this one, we're given an equation r squared is equal to the square root of 3p all over 2p minus 1. We are making p the subject of the formula. I chose this question because it has two main areas. One, how to undo the square, and this one should be read as how to undo any other root. It could be a cube root, a fourth root, and so on. And also, students normally ask, whenever you are given this kind of instruction, make P the subject of the formula. Is this P or is it the P below here that we are making? And the answer is this, that the P is the same. It is for us to put it in one section of the equation, undertake factorization, and have it as one quantity. So let's look at the solution to this. In our solution, you find that our P is held by a square root. We have to undo the square root. How do we undo a square root? We undo a square root by squaring. We undo a cube root by cubing. So on and so forth. So we have r squared being equal to the square root of 3p all over 2p minus 1. We are saying step number 1 is to square both sides. By squaring, we are able to undo the square root. Remember, any value, let us take x, raised to power over half, is equivalent to x, the square root of x. These are equivalent. That means when I square both sides, when I square, I'll be able to undo the square. I'll be able to undo the square and get x. That is the theory behind what we are doing. So this gives us 3p all over 2p minus 1 without now the square root. On this other side, we use the rule of indices, which says x raised to the power of m, and then you multiply with n, comes to be x m times n, and the result there. So 2 times 2 gives you r raised to the power 4. At this step, we cross multiply. We take this as r over 1, so that our cross multiplication is so much easy. We cross multiply and we shall get 2p minus 1 multiplied by, this is what is going to be multiplied by r raised to the power 4, and this is 3p multiplied by 1, which remains as 3p. Opening up the brackets, we get 2p r raised to the power 4 minus, so 2p times r power 4, that is now r power 4 multiplied by 1, we get r to the power 4, and that gives you 3p. At this point, we put like terms together. Whereby we shall shift. We shift the p, the 3p, to be on this other side, and we shift this r power 4 on this other side. And that should give us, at this point, I use this space, that 2p r power 4, now this becomes minus 3p is equal to r raised to the power 4. We have the p and the p. We factor it out. And it will give us 2 r power 4 is what is left, minus. We factor out p and you're left with 3, and that gives you r to the power 4. So at this point, we can decide to divide out. We divide out by 2 r to the power 4 minus 3 on both sides. 2 r to the power 4 minus 3 on both sides, and this will cancel out. Normally we don't have to show the cancellation, but I can say this divides out, we get 1, this divides out, we get 1, and therefore p comes up to be r raised to the power 4 all over 2 r raised to the power 4 minus 3. So depending on how you tackle that question, you find that some students will also get an equivalent answer, which is p is equal to negative r raised to the power 4 all over 3 minus 2 r raised to the power 4, whereby depending on the order, this 3 comes first, as we have shown here. Both answers are correct. So in this kind of a question, we need to see how to mark it out. You find that when the student commits himself that he's going to square, we wait for the result of the square of undoing the square root, and when he does it correctly, we give m1. Then we look for the second step, which is putting the like terms together and factoring out p, and that is happening at this level, m1, and when the student gets the accurate answer, we get a1, and that earns the student 3 out of 3 marks. So this is a typical case of making one variable in a formula the subject of the formula, meaning the formula will read now differently after changing from r squared is equal to square root of 3p over 2p minus 1 to p is r power 4 over 2 r power 4 minus 3, and that those steps will vary depending on the question. I would like us to look at question number 2. Question number 2, which will guide us further in how to undertake these questions in formula. So viewers, I'd like us to write question number 2 and we work it out together. Number 2. We are required to make Z the subject of the formula. Make Z the subject of the formula. The expression given is that we have T is equal to 1 minus P Z squared all over K Z squared minus Q. So this is our expression and we are required to make Z the subject. We had said earlier the Z is the same. So it's upon us to work it out and see how to get it. Straight away, let us get moving. Let us work it out. Step number 1 is to cross multiply. We have T multiplied by K Z squared minus Q. So we cross multiply this up here, and here we can assume there is a 1 which we shall cross multiply there. And that gives you 1 minus P Z squared. So 1 times this, it remains the same. So we open the brackets here and we get K Z squared T minus QT is equal to 1 minus P Z squared. Now, in this step, we need to look at what are we doing. We are interested in making this Z the subject of the formula. So we shall have this Z as PZ squared brought onto this other side, while this part here taken to this side. That gives us K Z squared T plus, we add PZ squared on both sides. And that's so we get P Z squared is equal to 1 plus QT. So we add QT on both sides, it is over here. That ensures that the Z is on one side. Step number 3 is to factor it out. We factorize out Z squared, we get KT plus P. So we remove the Z which is here and replace it here. And that will give us 1 plus QT. Step number 4, we divide out KT plus P, will divide by KT plus P on both sides, such that all this divides out as 1, divide out as 1, and this divides out by 1. So we are left with Z squared being equal to 1 plus QT all over KT plus a P. Now, viewers, this step is not what we were asked to get. We are asked to get Z. So we need to square roots on both sides to get Z as the square root of 1 plus QT all over K plus, that is KT plus P. But remember, this being a square root of a positive number or a positive item here should give us either a positive or a negative result. So this is very important that we remember on that one. Now let's come to award of marks. In this case, when the student is able to reorganize the question such that the Z is on its own side, we give M1 because the student is able to pick up and is able now to get to a very important step of factorization. When the student is able to factorize Z out, we give an M1, and finally, when the student is able to get Z on its own as an answer, we get an A1 for accuracy mark, and that question earns the student 3 out of 3. So this is a series of questions that we feel that learners, we should have the skill so that we are ready for that. Viewers, I would like us to look at activity 1. This activity 1, we shall answer it in the live section. We look forward to getting your views and your answers during the live section as a narration in terms of how did you answer the question. Activity 1. We are required to make S the subject of the formula. The subject of the formula in the equation R is equal to 3SV all over S plus 4Q. So we are required to make S the subject. So viewers, take time during our live section. We shall work on this one and give a response immediately on what we are going on what you have gotten. Now we are moving to part 2 of the topic variations. So let us move on to part 2. Part 2 on variations. We have 4 forms of variations. 1, we have direct variation. 2, inverse, also known as indirect variation. We have 3, joint variation. And 4, we have partial variation. Now viewers, it is important to notice that the major variations are 2, direct and inverse. Joint variation uses both direct and inverse in terms of how we compute questions in it. Partial variation has direct and inverse also. So the major ones are the first 2. However, these 2 uses the knowledge of direct and inverse. So let us look at how is joint variation. How is direct variation? I beg your pardon. Direct variation. You find that when 2 quantities, let us say P varies directly. P varies directly as Q, or as square of Q. Square of Q. How do you express this one? So the quantity is P and it is varying directly as square of Q. How do you show that one? We show it in 2 ways. The relationship P varies as directly as the square of Q. And this one is written as an equation. P is equal to KQ squared, where K is a constant of proportionality. In B, we look at inverse variation. Inverse variation. How do we relate that one? We have, for example, P varies inversely. It varies inversely as the square root, of Q. How do we show that one? We show that as P varying inversely as the square root of Q, which we show here as a rule or as an equation. P is equal to K, which is the constant of proportionality, all over the square root of Q. And we are saying that K is a constant of proportionality. It is important to note that one. So we just illustrating how this should be done or how it should be written. 1 over is the symbol for the inverse. Number 3, we look at cases of joint variation. In joint variation, we have 3 minor or 3 classifications that we can have under joint variation. A, whereby we have P varies jointly as Q and as square of R. Viewers, it is important to notice here that I have not given the direct commitment of, is it direct or inverse? When that situation happens, we take it and we assume it as direct. So we shall take it that P is varying directly as Q and as square of R. And that relationship, as a rule, becomes P is equal to K, Q, and we are going to multiply. The dot here means multiply by R squared. So that is the relationship in joints where both of them are varying directly as one another. In B, we can look at a different case. P varies jointly directly as Q and inversely as square root, for example, square root of R. How is that? You find that this being a joint variation, one part is direct and the other one is inverse. So how is that going to be? We have P varying directly as Q and inversely as square of R. And that comes as an equation. P is equal to K, Q, K multiplied by Q, all over R squared. So this is the joint variation, which is using the direct and the inverse. As we had said earlier, joint variation uses either this for 2 constants or more, or a combination of the 2. However, we can have a third form whereby we have 3 quantities vary with an inverse, a double inverse. How is that? P varies inversely as Q and inversely as cube root of R. So viewers, I would like us to see the inverse case and the inverse in one. So how is this going to be? P varies inversely as Q and inversely as the cube root of R. And that as a relationship or as a rule will become P is equal to K all over Q multiplied by the cube root of R. So both of them are below as denominators since they are in the inverse case. And we shall look at various examples to this case. Finally, I would like us to look at number 4. We use this case. Number 4, for partial variation. Partial variation. In partial variation, we have 4 different scenarios whereby A, we can have a quantity P varies partly as a constant, and partly as the, maybe you can say, square of Q. How do we put this one down? How do we write this one? We say P is equal to a constant K. It varies partly as a constant, and that is the one we are showing here, plus partly as the square of Q. So we shall have another variation constant here, proportionality sign here M, so that now Q can vary as its constant. So this is the expression. P varies partly as a constant, which we put K, beg your pardon, plus partly as the square of M. And then when we get to this kind of a question, we substitute the values that we shall be given. Let's look at condition B on partial variation. We may have a case of inverse B, whereby P varies partly as a constant, and partly inversely as maybe we can use R. How is this? We say P is equal to, it varies partly as a constant and inversely as the variable R. So we have part constant, part inverse. Let's look at C. We have a case whereby a variable P may vary, P varies. We look at inverse in both cases. It varies partly inversely as Q and partly inversely as R. How is that? We have P varying partly inversely as Q, so we have K all over Q plus partly inversely as R. M is a constant, is a proportional sign all over R. And we can have a different sets of this coming up in different ways. Maybe there is only one which we have missed, and that is double direct variation. Maybe D. We talk about P varying directly, as Q and directly as R. In this kind of a case, we may be given P varies as Q and as R. When the word directly is not placed, then we take it to be direct variation. If inverse is implied, it will have to be stated, and therefore that comes to be P varies directly as Q and directly as R. You can see each of them has its constant of proportionality. So viewers, we are now going to the final section whereby we shall look at real-time, real examples in each of these cases of variation. Let's look at the examples. Example 1. We look at a case of direct variation. X varies directly as the square root of y. When x is equal to 2, y is equal to 16. Find x when y is equal to 36. So in this case, we look at directly. So x varies directly as the square root of y, meaning x is equal to k square root of y. We put in these values given. We have x is equal to 2. We don't know the constant of proportionality, but we know square root of 16. That means 2 is equal to, square root of 16 is 4, and then multiply by k. We divide by 4 on both sides, and we shall get that k is equal to a half. Now that means we bring in the equation x is equal to a half square root of k square root of y, sorry. So this is the equation that connects x and y. What is the value of x when y is 36? So x will be a half times the square root of 36. And that comes to be a half times 6. Therefore, x is equal to 3. So in this kind of a case, we mark when the student has able to substitute correctly into the correct variation. The constant here is extremely important. So M1, and it's being used correctly, and you have A1 3 out of 3 in that kind of a question. Let's look at a question on inverse variation. This question will be an activity which we shall report in the live section. Viewers, let's put it down. P varies inversely as the square of r. P varies inversely as the square of r. When P is 32, Q is 6. Or P is 32 when Q is 6. Find the value of Q when P is 24. Find the value of Q when P is 24 and give your answer to 4 significant figures. We shall work it out during the live section and do the reporting for that. Let's look at question number, example number 3 on partial variation. A quantity y is partly constant and partly varies as the square of x. So here we are seeing partly constant and partly varies as square of x. How do we write that? So we have y being partly constant and partly varying as square of x. So we have that. So this is very important. Y is partly constant and partly varying. So we need a constant of proportionality for this variation as x squared. Then we put in and form two simultaneous equations. When y is 40, then x, we have a constant for equation 1, x is 2. We put 2 here, x squared becomes 4. 4 times m is 4m, and that becomes our equation 1. Then we have when x is 3, y is 65. So we have y is 65. We have the constant of proportionality. Then we have x is 3. 3 squared is a 9 multiplied by m, and that becomes our equation 2. So we solve these two equations simultaneously by elimination, and the best thing is to eliminate the k. So 9m minus 4m gives us 5m. 65 minus 40 gives us 25. So if 5m is equal to 25, divide by 5 both sides, and we shall have that m is equal to 5. So we use this to get the k. Using the simplest equation, we shall have 40 is equal to k plus 5 is the value of m. So 4 times m, which is 5, is 20. And that means our k is 40 minus 20, k is 20. Once we have k being 20, we write the equation of y as y is equal to 20 plus 5x squared. Because m is 5 and x is varying directly as x squared. Now we look at the value of y, we search for the value of y when x is 4. So this will be 20 plus 5. We substitute x for 4. So 4 squared is 16. From your calculator, 5 times 16 gives you 80 plus 20, and that comes to be the value of y. Therefore, y is equal to 100. In this kind of a lengthy question, we may award 4 marks. Where the student is able to develop these two simultaneous equations, we get M1. This constant M1, very important. And even when we have now this equation M1, so far we have awarded 3 marks, and this is an A1, giving 4 out of 4 in that case. Straight away, let's look at a case of joint variation. In the joint variation, we are saying 3 quantities, P, Q, and R, are such that P varies directly as the square of Q and inversely as the square root of R. So this is a combination of 3 quantities which are varying directly but in different formats. So let us see, how is this? We are saying that P varies directly as the square of Q and inversely as the square root of R. That means P will be equal to a given constant K all over times Q squared over the square root of R. It is important, viewers, to note that we do not have 2 constants for the direct case and for the inverse case. It is 1. So with that, let's look at this part given here, whereby we are told that P is equal to 20 and Q is 5. So we shall have K multiplied by 5 squared, which is 25. And then we are having R is 9. So square root of 9 is a 3. So we multiply 20 by 3, that gives you 60, is equal to 25K. We divide by 25 on both sides by 25, and we get that K is equal to, from your calculators, let us see, 60 divided by 25, we get 2.4. So the equation linking P and the Q is that P is equal to 2.4 Q squared all over the square root of R. And this is a very good case of joint variation. We are moving to the final part, which is to get an activity for example 4, and that is coming right away. Activity 4B is on the question that we have cleared, given that P jointly varies as the square of Q and inversely as the square root of R. Find the percentage change in P. Find the percentage change in P if Q increases by 20% and R decreases by 36%. This is an activity which I would like you to think about and report in our live section. The expected answer is increase by 80%. Let us see how you go about it. And our final activity, which is an exercise which you will report live section, is on partial variation. A quantity Q varies partly as R and partly as the square root of R. When R is 4, Q is 14. And when R is 9, Q is 27. Find the value of Q when R is 16. So note it down in your notebook, and our expected answer is 44. Viewers, we come to the end of the recorded section as we move to the live section, And all this material is available on our educational YouTube channel using the handle at Steve Gitau. At Steve Gitau 3660. At Steve Gitau 3660, you will get all these videos in mathematics and in chemistry arranged in form of folders. On the playlist, you get these folders from Form 1 to Form 4 mathematics, and the second subject, Form 1 to Form 4 chemistry. Thank you for being there. Let's see you in the live section. See you then.